Right, in the second half of today's video reference, we're going to learn how to solve absolute value inequalities when there's stuff less than or equal to or greater than or equal to another number. But I'm going to try to first attempt to why when we write the second version of the inequality, why we switch the symbol. So if you can try to copy this down on the little margin here. So basically, going back to the absolute value of x is greater than 3. So if we think of some stuff that works for that solution, 5 would work, but then you could also say that the opposite stuff would work too. So that means like -5, if you plugged it in there, would also be, the absolute value of that would still be greater than 3. Same thing if you took 10, that works, but the opposite stuff, absolute value of -10, also works. So whenever stuff you get, the opposite stuff also works. So now let's do that with a less than. So absolute value of x is less than 3. So some stuff that would work would be like 2. Some opposite stuff that would also work would be like -2, because the absolute value of -2 is 2, which is less than 3. Some other stuff that would work would be like, I don't know, 1 is less than 3. The opposite stuff would also work. -1 is less than 3. So now that brings me to my little proof here, if you will. So the absolute value of stuff, let's say, is, let's just do greater than or equal to, let's just say 7. I don't know why. So that means that the opposite stuff will also work. So opposite stuff, sometimes you do negative to indicate this means opposite stuff is greater than or equal to 7 will also work. So if we want to just get, instead of opposite stuff, just regular stuff again, you're going to divide each side by a negative, because remember, this is a assume -1 right here, and we never distribute inside the absolute value symbol. So this is divide each side by a -1, divide by a -1. But when we divide by a -1, that switches the inequality. So then we're left again with stuff, absolute value of stuff, and now we switch it, is less than or equal to -7. So when you write your two possible solutions, you have to have stuff equal or greater than or equal to the positive version of the answer, and then you write the -7, but then you have to also switch the inequality. So it's just like before in a previous video reference. If I kind of flip back here, like we had, the answer could be 3 and -3, 15 and -15. So, we would go here, we write 2x minus 7, absolute value is 3, so we'd have to write the two equations. So it's the same thing with inequalities, except when you write the two equations, your second one, yes, you're going to make it negative, but for all the reasons I just explained, you're going to have to change. When you make the negative version of your equation, you're going to have to switch the symbol. So that was a long explanation. So now we can actually try example 2, and you might have to rewatch that again if that didn't make sense to you. So now we're going to, it's already stuff less than or equal to 12 in absolute value, so we can make this into two equations. So the first one I'll just write for you is going to be 3 plus k is less than or equal to 12. And then we learned yesterday for Math by 5, so this is less than, to use his analogy. So we will be able to have a raise your hand, will it be a barbell or split? So this will be a barbell. Okay, so now let's go ahead, and can someone tell me the other equation? See if you can do that. So it'd be 3 plus k is greater than or equal to negative 12. So again, you're still going to do the negative version of this, but we're going to switch it from less than or equal to greater than or equal to. So now we're going to solve. So minus 3, k is less than or equal to 9. And then we, over here, minus 3, k is greater than or equal to negative 15. So now I want to put that on my solution graph here. So we'll go, and it should give us that barbell. So we're going to go to 9, which is 4, 6, 8, 10. So 9 would be like right here, close dot. Negative 15, this would be negative 14, negative 15's here, close dot. And then follow the way it goes. That's less than, that's greater than, so it does give us that barbell. Okay, let's try the next one, example 3. Okay, so before we can break it up into two inequality, the first thing we have to do is get that stuff by itself. Raise your hand, what's the first thing we'll do to both sides? Plus 6, plus 6, and I'm left with absolute value of n minus 3 is greater than or equal to 9. All right, so now we have to break it up into two inequalities. Raise your hand if you can give me, see if you can give me both of them. So it would be n minus 3 is greater than or equal to 9, and then n minus 3 is less than or equal to negative 9. Again, switching the symbols. For Scoosh, can you tell me, this is the greater then symbol. Is it going to be a split or a barbell? It's going to be a split when I graph the solution, so keep that in mind. So I'll pause the video here. Could you maybe try to solve and graph these? All right, if you did it right, plus 3, n is greater than or equal to 12, plus 3, n is less than or equal to negative 6. So now when we do the graph, it should give us that split, that or scenario. So I'll just go here, negative 6 here, close dot, and going in this direction, and then positive 12 here, close dot again, going in that direction. So again, hopefully this kind of made sense. This whole explanation hopefully made sense of why we switch when we write the negative version of it, why we switch the inequality, because again, we're technically divided by that negative 1.